In this short video, I give you an introduction to the notion of groups, and I also refer you to the corresponding lecture notes. So what is a group? To understand what a group is, let's take back and think about our time in school. Well, currently my kids are in school, so it's essentially quite nice for me to follow this. So the way they learn math in school at the very beginning is that they learn, for example, what is 3 plus 4. And this question, in fact, is also the question when it comes to groups. Groups are a very beautiful abstraction how a certain operation is done on sets. So let's go back to the example of 3 plus 4. If you look at this example, what is really happening is that you have a certain operator, and the operator in this case is the plus sign. And the plus sign is an operator that requires two inputs, the 3 in this case and the 4. And this operator is then transforming these two inputs to a certain result. In the case of 3 plus 4 in school, right, they learn it's 7. And groups are a very beautiful abstraction on the question, if we have certain sets and we perform operation on these sets, then what is actually happening in this case? And we will now take a closer look on the definition of groups and understand how these operations are done on the sets and what kind of law and rules actually hold for the groups. So stay tuned. What is a group? Formally speaking, a group is a mathematical structure of a set G where a certain operation is defined on the set. So here in this example, I used the star to make sure that you are aware that could be any operation. In math in school, usually you think of things like plus, minus, multiply, or whatever. But in fact, this can be any operation, and we will see a nice example soon. And the basic fact here is when we apply this operation to these sets, then, or to be more precise, when we apply this operation to elements of the set, then the result that we will get will also end up in the set. So it cannot happen that if you, for example, you use the star on two elements, that you're going out of the set. So you will always remain within the set. Furthermore, it is required that there is a neutral element. And the neutral element means that whenever you apply the group operation to an element in the neutral element, then essentially you stay with the first element. Furthermore, there's an inverse operation. And as you can imagine, as the name suggests, the inverse operation reverses what you did before. So to be more precise, if you apply the group operation to an element and to its inverse element, then you will end up with the neutral element. So I promise to give you an illustrative example that is not using the typical operations of, let's say, math, plus, and multiply. So the example that you can see here is the one of a symmetric group of geometric object, e.g. the square. Right? So now you see the square, you can essentially see we can perform certain operations on the square. For example, we can rotate the square, and we can reflect it. With respect to rotations, it's not hard to see that if you rotate it by 90, 180, 207, and 360 degrees, then we will always essentially have the same appearance. Furthermore, with respect to reflection, we can reflect the square on each of the 4 axes, as you see here in this nice picture. And then, of course, you will end up with the same object. So what are the elements in this group, and what is the group operation? Well, the group consists exactly of these 8 possibilities as we have just seen, namely the 4 rotations that we saw and the 4 different reflections. So the elements are 8 in total. The number of elements are 8 in total. And what is the group operation? Well, the group operation is simply the concatenation of the individual operations. So this gives us a very nice and illustrative example where we perform certain operations on elements that are not exactly the typical operations of plus and so on. So now let's take a look what the axioms of a group are and how we can actually work with it. And this brings us finally to the definition of a group. A group, as we said before, consists of a set and an operation that is defined on this set. Furthermore, in order to be a group, it must satisfy the following properties. The first property we already mentioned, that's called closure, and it essentially means that whenever you're performing the operation on the set, you will end up in the set. Which means for all elements A and B out of G, whenever you apply the group operation to both elements, the result will be in G as well. The second property is called associativity. And it essentially means that the ordering in which you apply the operation is not important, which means if you have three elements, A, B, and C, out of G, then you essentially can first apply the group operation to A and B, and then the result again apply to C, or you do it the other way around, which means you essentially apply the group operation to the other two elements in different order, you will always obtain the same result. The last two properties we've already discussed, and it's essentially the neutral element, which means that whenever you apply the group element to the neutral element, the element will stay the same, and this must hold for all elements in this group. The second property that we already discussed before, that's the inverse element, and it essentially says that for all elements there exists one inverse element, which has the property that if you apply the group operation to both elements, then you will end up with the neutral element. And in many cases we will essentially use the 1 as a neutral element. But don't think of the 1 as being the actual number that you use, right? So for example, if you think back of the illustrative example that we have seen before, right, that the neutral element, for example, would be the rotation of 360 degrees. Finally, we will also introduce the notion of Abilene groups, which is super useful in cryptography. So Abilene essentially means that the operation is commutative. And being commutative essentially means it doesn't matter in which order you apply the group operation. Which means it doesn't make a difference whether you apply A and group operation B or whether you apply B group operation to A. Right? So the ordering in which you insert the arguments into the operation doesn't matter. You will receive the same result. Now let's take a look at 3 easy examples that should help you to understand or essentially determine whether a certain set with an associated operation is a group or not. Well, here we have these 3 examples. The first one are the natural numbers, and the corresponding operation is the addition. The second example is the set of integer, again where the operation is the addition. And the last one are the rational numbers, where we use as an operation on this set the multiplication. So you may want to stop this video at this point, sit down and think about whether these 3 examples form a group and whether it's an Abilene group or not. So let's take a look at the first example, the natural numbers. It's not hard to see that the natural numbers actually do not form a group. And the reason is that we are missing inverse elements. For example, if you take a look at the 1, then it's easy to see that -1 is not part of the set, and therefore there is no inverse element. So what about the second one? Well, z plus, in fact, so the set z of all integers together with the operation plus forms in fact an Abilene group where the neutral element is 0 and the inverse element of an element A is -a. So last but not least, we also have the set of rational numbers, the q, where we use 0 as a corresponding operation on the set. So in this case, it is not a group, and the reason is that q in general contains the element 0, and 0 of course has no multiplicative inverse. However, if you remove this element out of the set, then you will obtain a group. So this concludes the short introduction into groups, the basic operations. I hope you liked the video. Many thanks for watching, and we will see us either in class or in the next videos.